This is the Electrolab Fermenter benchtop fermenter system. We have 3 of these units here. They're about 10 to 12 years old now. They are in regular use. Electrolab is a British company. They're based in Tewkesbury, down the M5, so not too far away. The system has 3 principal components. We have the vessel itself, we have the stirrer rig, and we have the controller. So, starting off with the vessel. It's a glass body, flat bottom, straight side, 5 litre capacity. The 5 litres is measured all the way from the bottom right up to the brim. We normally operate at around about 4 litres to give ourselves a 20% headspace, and as a rule of thumb, the 4 litres is roughly where the Electrolab label is. Top plate is stainless steel. Machined into it are various ports, and starting at the front, these are the 2 vital probes. We have dissolved oxygen and pH. Right behind them we have 2 addition ports here, and this is where we can connect in a sidearm flask like this for adding our inoculum plus any additional feed. Moving around clockwise, just move that out of the way, we have this little fitting here, 2 parts. In there is a septum, so if we need to add anything extra, such as a dose of concentrated anti-foam if it starts foaming up, we can put a needle through there. Next we have a dip tube. This runs down into the vessel, stops about 1/3 of the way off the bottom, and we have a fitting on here into which is screwed a wide neck universal bottle. This is our sampler, so this enables us to take out a sterile sample. With a little modification, this can also be used to harvest the vessel at the end of the run. At the back, this is our condenser. These 2 beige coloured tubes here is the water supply, and this is where all the air exits from the vessel. The purpose of the condenser is to knock out any moisture that is entrained in the exhaust air, and the exhaust air comes all the way up this long tube here, and that is our air outlet filter. It is considerably larger than the air inlet filter, simply because if this does get blocked with any moisture, any foam that gets past the condenser, this will still function. The pressure will not build up. If this does get seriously clogged, the pressure in here will build up and up and up and up until at some point one of these things will burst off. One of the reasons why we have everything sitting in a tin tray is to contain any spillages and the like. Alongside the condenser we have a blind pocket here for our temperature probe, and then this here is our cold finger. Again, these 2 beige tubes here is the cold water supply. It's all part of the temperature control system. The temperature probe from here reports to the controller. If it's a little bit on the cold side, then power is sent to the heating mat, which you'll see a little bit later on to warm it all up. If it gets too hot, then the controller will instruct a solenoid valve to open to send cold water through this cold finger. Acts a bit like a radiator in reverse, extracts a bit of the heat and puts it into the water. Next along here, this little fitting is a little sort of triple header, also known as a trident. This is where the additions go in for pH control, your acid, your alkali and your antifoam. It's a clever way of using just the one fitting. Of course, if you're not, it'll easily unscrews. There we are, quite a clever bit. So you normally have a little tube on each of those and a connector. If you're not intended to control the pH, then you can very simply put a blanking plug like that in. And over here we have our sparger with our inlet air filter, and the sparger is a big long tube, goes right down to the bottom then across, so it sits underneath the impeller. That is how our air gets into the vessel. And in the middle we have the shaft, the impeller shaft. It's top mounted, and that's all running quite nice and freely. And we have currently 2 impellers on there at the moment, Rushton turbine 6 blades. The impeller, top plate is held onto the vessel by a spring-loaded clamp. Very simple. That just flicks off like so. Pop that open, and drop down, and then this can come off. But we'll come to that a bit later on. When reassembling it, just make sure you don't catch any tube on the way. And just pop that in, and there we are. Right, turning to the rest of the system. The stirrer rig, it's stainless steel construction. At the back here on this panel we have the entry points for our compressed air. Compressed air can come either off the bench tap at the back, runs into a little solenoid valve here, or we can use a separate air pump. Again, swap the tubes over. Always make sure this valve here is switched to on. Above it we have the sockets for the condenser. They are designed so you can't muddle them up, so that the flow goes the right way. Over here the sockets for the cold finger, and this is where the cold water comes in. That is currently switched on. Normally we would use tap water for cooling, but as this lab does get rather warm, especially during the summer, tap water is nowhere near cold enough, so we use a chiller unit in the corner. All 3 vessels are plumbed into this. So before switching on, make sure there is some water in it. We don't use antifreeze, because in the events of leaks, antifreeze is a little bit messy. We just use normal tap water. At the top here is our electric motor. Inside here there's a belt drive and a shaft and a universal coupling which connects onto the top of the shaft. We have an RPM display and a power indicator. The power indicator is a purely arbitrary scale, 0 to 10. That's just to give you a visual indication of how much power the motor is putting in. Obviously, the higher the RPM, the more viscous the medium, the more power the motor has to put in, so that will be all the way up past 6. Obviously, you don't want to run at a high speed for a sustained period of time, otherwise you will burn the motor out. This controller can either be set to run independently on its own. We can set our speed here, or we can have it under external control. There's a little indicator light here, and the controller here will run the stirrer for you. The controller is bolted onto the side of the frame. We have all our leads for pH, temperature, dissolved oxygen plugged into the top. The leads for the air and the cooling water solenoid valves come off here, and this is our wraparound heating mat. This all wraps around the vessel, held in place by a couple of elastic cords which we keep up on the side here so they don't go wandering off. This is our rotameter. It runs from 0.6 to 5 litres per minute. And these are our leads for the probes. Just swing those out of the way for a moment. We'll switch on. They are plugged into the mains at the back, normally kept switched on, so main power is on here. Makes a few bleeps, the screen lights up, we have a countdown timer, we press enter. Our first menu that pops up is the setup menu. We press escape to bypass that, and we're on the main menu. You can see 4 columns there. On the left, our main parameters: agitation, temperature, pH, dissolved oxygen, pump 1, foam 1. Next along we have our actual values. Now the agitator's not going round at the moment, which is why it's saying -2. The temperature probe is picking up 20.6 degrees, pH and dissolved oxygen, well that's gibberish at the moment because they're not connected to a probe. We won't worry about these two at the moment. SP for set point, so here are our set points, 250 RPM, 37 degrees, pH 7, dissolved oxygen level 50%. And our final column is our on-off control, which we can toggle between on or off via the enter button. We can scroll around here with the arrows, like so, and back up to the top. So all pretty sort of straightforward. So what we'll do now is we'll put the vessel onto the stirrer rig and we'll show a few of these little controls, then we'll get on to probe calibration. Before picking this up, make sure the clamp is tight. And then just a firm grip underneath. Place on the tray. Air outlet tube, just feed that back behind the frame. Shuffle everything forward, get it lined up with the arms, then there should be 2 bolts. They drop through the holes and screw in. So this is going to stand in the right place, it's not going to fall over and land on the floor. Our sampler lives in the spring clip on the side there. We can pick up the air outlet filter, and that is held up at the top there on the retort stand. Now the simplest way to plug everything in is to, I find, start at the back, work your way through to the front. So, condenser tubes connect in like so, cold finger we then find our temperature probe lead, and then gradually insert that into the pocket. You need to push down quite firmly until you hear it reach the bottom, which is there. For the shaft, line up the pegs on the shaft with the connector, push down, then a slight twist to lock. And then don't forget the safety guard. That clips on the top like so your fingers won't get mashed up when it's running. pH lead has the orange bit on the end. Then locate it and screw down to lock. Dissolved oxygen is a little trickier. You have to sort of line up. You can see there's 4 pinholes there and there's some little lugs on the side which align there. Now normally you just have a little gentle push and twist and then locks like so. Inlet air filter, we find the silicone tube at the back of the rotameter, we pull that through and we connect up like so. Then finally the heating mat, get that lined up, get our little cords ready. Away. And there we are. Our fermenter is now ready to go.